In this video, we're again looking at particle movement and graphs. This time we're going to look at how AP might give you a trick problem revolving about net distance and total distance. Remember that in order to go from velocity to position, you need to do integration, and integration is area under the curve. So it looks like we need to integrate from 0 to 4 of velocity dt, and then it also looks like we're going to need to integrate from 4 to 6 of velocity dt, and then we're going to need to integrate from 6 to 8 of velocity dt. Now here's our problem. Area under the curve, if we look at our first integral from 0 to 4, the area under the curve is actually this two slivers here. Well, how are we going to get those two slivers? Well, we're going to have to be sneaky, because what we're going to want to do is find the area of the rectangle and then subtract from that the area of the semicircle. If I do that, if I were to take the semicircle and I were to get rid of that, notice what's left are the two slivers that I want. So I need to come over here and I need to take a look at the rectangle involved. Now notice that that rectangle is 2 by 4, or 8. I need to subtract from that the area of the semicircle, which is half times pi times radius squared. Our radius is 2, so I've got 8 minus 2 pi is the area of the slivers down here in green. So that's my first piece. So my first piece is 8 minus 2 pi. Now that's positive area because it's above the x-axis. Next, we would now need to find the area of the triangle from 4 to 6. So that would be half of base 2, height of 2, which would be 2. Again, that's positive area because we're above the x-axis, or in this case the t-axis. And then our final integral is going to be the area of the triangle down here below the x-axis. So that would be half. Again, it's 2 times 2, but now it's a negative 2 because we're below the x-axis. So if I want to do total distance, remember, total distance, we have to take the absolute value. So I've got an 8 minus 2 pi is my first piece. I've got a positive 2 for the triangle above the axis, and then I need to make that third triangle also positive because it's below the x-axis. If I combine like terms, I would get 8 plus 2 is 12 minus 2 pi. If I want net distance, then I leave the signs the same. So my first area was 8 minus 2 pi. My second area was a positive 2. My third was a negative 2. Well, those are going to cross each other out. We probably could have told that just by looking at the picture. And so our net distance is simply 8 minus 2 pi. So be very careful when they give you semicircles as to how the semicircles are facing, because they love to do this sort of trick.